All right, and this is 2.2 polynomial functions. So let's look at this one. I believe we did this one yesterday. So we're going to look at quartic functions. So consider the shape of a few typical third degree polynomial or cubic functions, right? Looks like this. And fourth degree polynomial or quartic functions. So quartic functions look like this. It looks like a flat parabola, kind of flat here on the bottom. All right. Or it could have like an M shape there. Okay. So those are what some cubic and quartic functions look like. And notice the zeros here. For cubic, we have 1, 2, 3, or we just have 1. Okay. For the quartic, we have 1, 2, or we have 1, 2, 3, 4. All right. So what we're noticing is that quartic functions, they can have at most 4 zeros. And cubic functions, they can have at most 3 zeros. Now, if you're wondering, is that related to their degree? The answer is yes. Yeah, so if you have that cubic function here, right, it's possible to have 3 possible zeros. And a quartic function, 4 possible zeros. So whatever that that n is, whatever that exponent is. And then the turning points. So the turning points, remember, are where it changes direction. So from left to right, here it's decreasing, but then suddenly at this point, it's increasing. So it's a turning point. So this one has 1, 2 turning points. Okay. And here it doesn't have any. Um, here it has 1. Here it has 1, 2, 3 turning points. Now the turning points, this one can be 1 less than this degree. So this 3 minus 1 is 2 possible turning points. All right, and here for the quartic, it's 4 minus 1. So 3 possible turning points. And we are going to see that on the next page, next slide. So let's look at that. Let me say this on the notes first. All right, so that's what this is talking about. So a polynomial function f of degree n is greater than or equal to 1. So if the n is greater than or equal to 1, so basically if you don't have a constant function, has at most n distinct real zeros and at most n minus 1 turning points. Okay, so just like what we said. So like if we had x to the 7th, then it could have 7 possible zeros and 7 minus 1 or 6 possible turning points. TP, turning points. All right, and this just helps us to get a good idea of what the graph looks like. So recall that if a polynomial function in C is an x-intercept of the graph of f, then it is equivalent to say that C is a 0 of f. X equals C is a solution of the equation f of x equals 0, and x minus C is a factor of the polynomial f of x. And we'll look at this later. All right, let's put this here in the notes. All right. Then we're also going to look at quadratic form. So you saw this in Algebra 2 already. Quadratic form is when you have a polynomial. You have three terms. And then you have, okay. So remember quadratic, it's the standard form is going to be something x squared plus something b, something x plus a constant. Okay. Now quadratic form is going to be similar, whereas it's going to be multiples of this. Okay, so we're going to use multiples of these exponents here. Okay, so it could be like a x to the, let's do 10th plus bx to the 5th plus c. All right, and you're probably wondering, what do you mean? Because we can look at this like this. We can think of u as x to the 5th. So if you think of u as x to the 5th, then this is actually u, a times u, and 10 is 5 times 2. So this is u squared plus b, and instead of x to the 5th, x to the 5th is, remember, just u plus c. And look at that. It looks just like a quadratic. So quadratic form means we can change it into a quadratic by letting a variable equal that x term there. Okay, whatever that middle x term is. Okay, so the thing is, the degree twice of this one. Okay, so whatever this number, whatever this exponent is, and twice of that has to be the degree. Okay, so it could be x to the 6th plus x to the 3rd plus c. It could be x to the 8th plus x to the 4th plus c. It can't be x to the 10th plus x to the 4th plus c, because here 4 times 2 is 8, not 10. So this one is not a quadratic form. All right. So let's put this on the notes here. All right. Sorry for the noise. All right. So let's look at some problems. Oh, repeated zeros. This one is really important. So repeated zeros are, you'll notice it when it's in factored form. Okay, factored form is where you have those parentheses. If any of them are squared, like this one is, then it's going to be a repeated zero there. Okay, and you learned in Algebra 2, like let's say you had, and we'll talk about this more later on in future sections. But here we have three different zeros, right? We have, sorry, we have x equals 0, we have x equals 1, and x equals -2. All right, but notice that this x, the 0, that's how we got the x to the 0, right? X squared equals 0, square root both sides, we get x equals 0. Because of this squared, that tells us that it's repeated there, okay? So it's repeated twice, okay? It's a repeated, and it's a 2. It's an even number. It's an even exponent there. So when it's an even, then that means it just touches. Okay, here, that's what they say, that's what they mean by tangent, where it just touches it. Okay, only crosses once at that point. But when you have an odd number, like x minus 1 is to the first, x plus 2 is to the first, whenever it's an odd exponent, then it's crossing. So it crosses at -2, it crosses at 1, but the 0, because it's a repeated 0, it's an even number, 2, right? An even exponent. That means it doesn't cross, it just touches and then goes back. And this is going to help us to get a basic idea of what graphs, polynomial functions look like. So we'll look at this later. Put that in the notes. Repeated zeros. Pretty cool stuff. You'll use those on tests also. Because I'll ask you, what does a graph look like? All right. So here we want to state the number of possible real zeros and turning points of each of the functions. Then determine all the real zeros by factoring. All right. So let's look at 32 first. Okay. So should we do the harder ones first? Yeah, that's fine. Okay, let's start with 32. Actually, I'm going to move this a little bit to the left. So I got more space. There you go. All right. So right away, you'll probably look at this. You want to look at the degree. Okay. Define the possible real numbers. So here are n, the biggest exponent, n equals 5. So there's 5 possible zeros. Is 5. Turning points, possible turning points is 5 minus 1, which is 4. That's it. Now the next part is the tricky part. Determine all the real zeros. So this is where we have to find those zeros. So this is where we're going to factor it. Okay, when you look at that, you might think, whoa, that's a big polynomial. Yeah, it is. So what we want to do first is we want to notice that we don't have a constant. And you gotta have a constant. Okay. So here we're gonna make this into a constant. How do we make it into a constant? By factoring out your smallest variable term. Okay. So here we have an x cubed. So we're gonna we're gonna factor out an x cubed from everything. Okay. And when we do, what do we get? We get 3 plus 11 minus 20. Okay. Oh, we can't factor out any numbers. Sorry, constants or coefficients. So we can't factor out any numbers, just the variable. Here, x to the 5th divided by x to the 3rd. So 5 minus 2, 5 minus 3 is 2. So you get x squared. Remember, when you divide the same base, you just subtract the exponents. Okay, so here, x to the 4th minus x cubed is x to the 1st, and x cubed divided by x cubed is 1. And that's what we wanted, a constant. So now we just want to focus on that inside. So we're just going to focus on this. We're going to leave that x cubed out for later. Okay, so here we have our A is 3, our B is 11, our C is negative 20. All right, and if you're wondering where'd you get that from, remember ax squared plus bx plus c. All right, and then you can factor however you know how to factor. However you know how to factor, that's fine. I'm gonna do it the way that I told the class. So factors of 8 times c that add up to b. 8 times c. So 8 times c is 3 times negative 20, which is negative 60. So we want the factors of negative 60. There's a lot. Okay. So we don't need to draw all the, we don't need to write all of them. I'm just gonna put down the main ones that it could be, right? It could be 1 and 60, probably not that. Okay. And here, notice that we're subtracting. Okay, so that means it's negative, so it's different signs. And because it's different signs, that's subtracting. And we want to get it to be 11. Okay, so if we subtract 1 and 60, yeah, it's definitely not going to be 11. 2 and 30, that's definitely not going to be 11. 3 and 20, that's not going to be 11. That's close, 17. 4 and 15, that is going to give us 11. So how is that going to give us 11? We have a positive 4 and a negative 15, or a negative 4 and a positive 15. Which of those is going to give us 11? So factors of 8 times c, that adds up to b. So which of those is going to give us positive? The positive is the negative 4 plus 15. So with that, we have, and now we want to write it as ax plus p and ax plus q. Okay, so our a is 3, so 3x and 3x minus 4 and 3x plus 15. And then this is where we want to factor. So this is the not mathematically sound one part. Okay, so you want to factor both. So is there anything that goes into 3x and 4? No, just 1. So you can't factor anything out there. How about 3x and 15? Yeah, 3. So we're going to factor out a 3. We're going to divide out a 3 and throw it away. That's the math. That's the reason why it's not mathematically sound. So we have 3x minus 4, and 3x divided by 3 is 1x, and 15 divided by 3 is positive 5. And there we go. Does that work out? 3x times x is 3x squared. Negative 4 times 5 is negative 20. And 3x times 5 is 15x. And then negative 4 times x is negative 4. So add those together. 15x minus 4x is 11x. Good. That works out. All right. And we want to find the 0, so we want to set that equal to 0, but this isn't it. Because don't forget we had that x cubed there as well. Okay, so we need to do the zero product property. X cubed equals 0. 3x minus 4 equals 0. And x plus 5 equals 0. And solve for x there. So cube root both sides, you get x equals 0. Add 4, you get 3x equals 4. Then divide by 3, you get x equals 4/3. Here, subtract 5, and you get x equals -5. So those are the three zeros. Ta-da! All right, and those are the answers. All right, we could do another one. Let me put this on the notes first before I erase it. I think we got time. Something smells good. Don't know what it is. All right, let's try 28. 28's one that has that quadratic form to it. All right, and I'll try to do it quickly so that we make it in time. And why don't you try 27? This is a good one. All right, so we're going to do 28. F of x equals 4x to the 8th plus 16x to the 4th plus 12. Our n, our biggest number, our degree is 8. So n equals 8. So possible zeros equals 8. And possible turning points, 8 minus 1, which is 7. All right. And then we want to factor it now to find the zeros. And then when you look at this, we can't do what we did in the last problem because we already have a constant, so we can't factor out any x's. Okay, so that's when we want to look at the powers. That's when we want to look at the exponents. So here we have an 8 and a 4. Hey, 8 is twice of 4. So we could change this into a quadratic form. So how do we do that? We're gonna let u equal x to the 4th. Always let it equal this smaller x term, okay? So here this becomes 4u squared plus 16u plus 12. Make it look just like a quadratic. And there you go. If you're wondering, how can you do that? Because 4 times 2 is 8. Okay, so it's okay. And u is x to the 4th, right? So if you plug in that x to the 4th, you'll get the same thing. 4 times 2 is 8, and you have x to the 4th there. Okay, so just focus on this. And now, since we're focusing on this one, we're going to try to get rid of that lead coefficient. Because notice that we have a 4 there, and these are all multiples of 4. What? So we're going to factor out a 4. And we have u squared plus 4u plus 3. 4u squared divided by 4 is u squared. 16u divided by 4 is 4u. And 12 divided by 4 is 3. So now just focus on this one now. And that's an easy one to do. So you could, since our lead coefficient is 1, you don't need factors of a times c to add up to b, just factors of c. Factors of 3 are just 1 and 3. And here, because that's positive, same sign. So that means you're going to add. Add to 4. And that's just going to be positive 1 and positive 3. Ta-da! So here we don't have x, we have u. Remember that. So u plus 1 and u plus 3. All right, and you can bring down the 4 if you want. It's okay. And then set it equal to 0. You have 4 equals 0, u plus 1 equals 0, and u plus 3 equals 0. All right. Now, if you want to switch out that u with the x to the fourth now, you can. Okay, this one doesn't work out. So here we have x to the fourth, x to the fourth. So subtract 1, we get x to the fourth. Huh? So we have negative 1, and here we have x to the fourth equals negative 3. Now when we do that, if we opposite of the fourth power is fourth rooting. So we're going to take the fourth root of everything. And uh-oh, this is where we run into trouble because we can't have a negative inside of a radical that has an even index. So because of that, because that's an even number, this does not exist. Does not exist. And same with this one, because that's an even index, we can have a negative number inside of that, so it does not exist. So there are no real solutions. No real zeros. And that's it. And the reason why is because this one, it will look like this. It will look something like that, where it's not crossing the x-axis at all. It's above the x-axis. All right, and that's it.